Okay, we got to do some announcements first. First off, these two sections are empty essentially. I was going to delete them all so that I could like make two new ones down here, but then it didn't let me delete them. So, yay. You basically got like free points essentially. According to my math lab, you go into the assignment, you click, 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 and you get them all right. And then you can actually do the real work down here. Is that okay? So yeah, I don't know. It's just a weird little setup, but you get free points. That's a little bit of bonus points, I suppose. But all the rest, I started deleting stuff starting from 16.2, I believe, all the way through. A lot more towards the end. Not as many here because they were still pretty easy. The goal here now, from here on out, is for you to ask me questions. And if you don't have questions, I have questions. And I did them from the homework. I said, that's a hard one. Let's do it. And so if you find something hard too, then yeah, let's do it. Perfect example is that we're going to start right here. Oh, wait, no, not that one. Right here, number 8. But this is what it looks like whenever I deleted something. It'll say this. So that's good. It means that you get a free point, actually. So that's kind of nice, isn't it? Yeah. No, it's all the same. Yes. So good to go. And I did skip this one on my own because I don't have this one on my list because I thought, oh, that doesn't look too bad. But if you think it's bad, then let's do it. Let's do it. It's all the better. All the better. That's what we're doing here. Is we're doing homework basically. Um, and oh, one last announcement is that I already posted the videos for the last two sections, 4 sections. And that way it's through the workbook. You got through the workbook, and now you have those problems, which were again directly from the homework. What I have here in my hands is the other ones that were not on the video. So that means we can do them in class. Cool? And I can make videos of that too if you really want me to, but I figured you wanted to come and see me. All right, let's do it. So, this thing. And I'm going to get rid of the blue bar because I'm really annoyed by it. Bye-bye, blue bar. Say bye-bye. Bye-bye. Okay. Blue bar? I thought it would go away. Okay, hold on. It will. I guess I just didn't hit enter or something. Oh my gosh, no. You're being mean, blue bar. Okay, well, I thought I could do it. We're going to do it. Just leave it alone. Blue bar's fine. We'll keep them around. So, integral of lots of stuff. Go. So, first off, we need a path of some kind. Basically, I need to know what my r vector is because that'll be my x and my y. So, let's make something up. This is what it's supposed to be. So, what would y equal? Just give me something silly. T squared. Okay, I'll even do t to make it proper. Awesome. And so, what would I put here then? Yeah, keep it easy, right? Keep it easy. So in a way, what I want to do is just go through and substitute all that stuff in there. I'm going to have an r prime because that will help me with the d's and all that stuff. Hello. So yeah, that's x and y. This will be dx and dy essentially. Derivative would be and then this guy. Perfect. So this is this is that, here and there. Plug it all in. Here we go. So I've got a t. I got a 3t squared. I have a dx, which is a 1 dt. Well, we'll do the dt at the end. Just 1. Plus x is a t. Y, 3t squared. Dy, 6t. And all that's just a dt. Now, I need to go from two different t values. And if you see here, we're going from this one to this one. Well, if you said that x was equal to t, so I'm going to go from... Perfect. I mean, if you want to use x all the way through, that'd be fine as well. It would be the same integral in the end, right? No wasting time, Desmos. No wasting time, Desmos. No wasting time, Desmos. I did that on my videos that I posted. I just went as fast as possible because we don't have the time anymore. Right here, it's 3t squared times. um, well, it's almost all over. I don't. Well, I mean, it's going to be fine. I don't know if that's right. So what I want to do is try it out. Obviously, that's why we're here. And good. That was excellent. Cool. I have questions, and we can do it. Whatever you want to come first. Is that okay, though? Is that good concepts? So, like, just convert everything to t, essentially. I don't want them to be. Do you want me to put them on there? No, I don't either. Yeah, it just would. On the quiz itself, I think there's only like 2 possible questions, so it doesn't make sense to put them on an exam because it's not a good pool. And I would never put Jacobians in a pool with other things because if one of you got a Jacobian, one of you didn't, then that'd be totally unfair. I don't like that at all. So I would say no. As of now, no. Okay. I just don't have enough time for all that Jacobian stuff. Let's do it. I'm all about it. 4. Okay. Yep, that looks a little weird. So I don't remember how to do this one immediately, but that's why it stumped the professor today. Right? Okay. Whenever I see a DS, I get super nervous, but I think what they're wanting to do is like the line integral thing. So I'm guessing here that I'm gonna do some kind of like a square root of some squares kind of thing, like a derivative squares, and then dt. I think that's because they have a t right there. That's what I'm supposing. So let's get through this. So x is equal to t squared. So I've got t squared squared. And then I got y is t cubed, and that's all to the 4/3. Let me just, again, on the side, make sure you see what I'm doing here. So that's my r, and so my r prime would be 2t and 3t squared. And I think that's what I'm going to be squaring here. Again, this is all just from memory. It's not really airtight. 1 to 2, and I hope we're done with that. I don't even want to simplify it. So let me get some Desmos up and just test it. Like at this point, I'm hoping you're seeing that all of it is about setup, right? We're setting the problem up, and that's about it. So this is a cube and a 3 cube root. They cancel, make a 4. Oh, look. Well, if I simplified, yes, it is. And they canceled out. Plus 9 t to the 4th. Okay. That's probably a square root answer. I'm going to get rid of this for a second. Okay. Because this all canceled. We didn't need that. So I'm running up against an issue, which I want to see if I can kind of loosen the grips a bit, okay? I know that this is going to be a square root of something minus a square root of something else. I believe we can get around it, but let me just verify a couple things. What we have here is 4t squared and 9t to the 4th. And they both have a t squared that I can pull out. So that would be a regular t on the outside. And I believe I would just have a square like that on the inside now. So I am going to do a u sub for this. It's a little unfortunate, but I think this is only the best way to do it at this point. So I'm going to divide by the 18 in the front. still from 1 to 2. And then I'm going to take all this stuff here to the 3/2, multiply it by 2/3. Oh, no. Right. Do y'all ever do that? Like you put the integral sign again? Okay. Yeah. Okay. So if I plug in a 2, then I'm going to get 9 times 4. Okay. Let me make that a little bit more clear right here. So then, yeah, let's do some equivalents. So 1/18 times the 2/3 times, and then I have, you said 36? And then you say the 4? Oh, if I plug in a 1. Oh, wait. Hold on for a second. Hold on. So you're saying if I do this, okay. We're good. No, we're good. And then if I plug in a 1, it'll be 13. Let me see if I get the same equivalent answer. There you go. So yeah, that would be the answer then. So in a way, like, I know that definitely go to Desmos first, but because I have a square root, I know we're going to get square root answers. I think there's a way around this. I think there's a way around this. No.
Upside down, so have it like be t1 to t equals 2. So on the top you have 1 and then 2 bottom. That gave me the correct answer. What I did the other way, it gave me a negative answer, but mine also, yours is a positive value, mine were all negative values for my integral.
So yours said 2 to 1?
Mine said negative 1 or
negative 2 to negative 1?
Yes, and I was getting issues of where it was negative, but it wanted a positive answer, so I had to flip this up, like flip them upside down.
Right, because negative 2 is technically more negative. See how I'm getting the same thing?
Right.
So that's probably on my math lab randomization thingy. But notice again, I am still doing from most negative to most positive.
Right. Just one more thing.
Yeah.
If you take the square root t and move it to the front, and just get the regular t out front. Then,
Yeah.
That's where I was kind of running into the issue.
Right. So it would look like this guy here. Oh.
That's what I was getting the issue of.
Okay, here, let me think about this. So it didn't work that time, but if I factor it out,
it only gets bothered. Like you can have a t square on the inside, you can factor all that out, but as soon as you pull that t out, it's negative.
so think about this for a second. I know that it has to be positive because its original started with all the squares. They all had even powers in a square root. So my original definitely would be a positive. Just looking at, like, basically looking at this guy here, there's no way to get a negative. So because I had to factor that out, now it's exposed and it can be a negative technically, but that doesn't mean the original should be. That's a very mean little problem. I mean, obviously on a test I give you full credit because it's just negative positive, but I would just be careful.
Yes, sir.
Yeah.
That was just one of those things I was like,
Thank you.
Yeah.
Thank you for spotting that. So real quick, I want to just verify. We got 9 times 3 is 27 in the bottom. I'm just going to start typing it. So 1/27 times all this stuff.
Actually, it's funny if you go like forward slash and then do like square root without it turning that, it still accepts the answer. I found that out. So if you copy it straight from Desmos, you can actually put it in there. It'll have words like square root.
Really?
I'll actually still take it.
That was not on the recording. Okay, give me another one.
That's all for me.
If not, I have my own. You just tell me, okay? You say, hey, Chad, and I got it. That's fine. Would y'all like me to do? Okay, So I'm gonna get started in 16.2, if that's okay. I felt like that's where the more meaty problems would be. Anyways, if I can ever scroll down to there. Okay, 16.2. Again, I'm picking problems that I did. So some of these might already say they're, oh, you already got them right because like I did them yesterday. So I'm not scared about any gradients because we can always take a derivative. This one, I think that y'all might have asked about it at some point, but it's been like that's in the workbook.
Yeah, that problem.
So you do not want me to do it?
You can. I wouldn't mind that. I
Okay.
found this morning.
It wasn't. Yeah, it's a little weird. So I just figured like, hey, it's a weird one. Let's talk about it. What we need to do is two separate integrals. That's kind of the leap here that we need to say. Oh, there's two separate integrals that I need to do. There's this guy, step 1, and then this guy, step 2. So let's do individually. Got an R vector. Just for the little first guy, what is my y value equal to right here on this little line? Always, right? It's always 0. And if you had to make like an x equal to something, it's not equal to 1, it's like traveling, right? So what would you say it could be? Just a plain t. And then we're going to go from 0 to 1. So we're like kind of creating our own little pathway. R prime, obviously we're going to need that, so 1, 0. And let's start plugging it in. So I have x squared would be a t squared, y squared is a 0 squared. And then dy, what's dy is a, ooh. So what do I get? You get 0. So this first part, there's nothing doing. Do it again. So now I got, for the second part, be careful here. What is my x value equal to always? 1. Always a 1. But my y, I'm going to now use a t. Again, I'm going to use 0 to 1 because these are separate. You don't have to go and make it something weird. And then r prime, 0, 1. So then I have x squared would be 1 squared, t squared, 1 dt. Calculator, because we don't waste time anymore. Yeah, no need to waste time. You know how many times I've done integral this weekend alone? And it was fun every step of the way. There we go. We did it. So 0 plus 4/3 is the 4/3. Exactly. Yep, you got it. Cool. Not too bad there. Waiting for y'all to copy down because copying is important. Or picture time. Picture time cool too. I have my folks in statistics class, there's like, I'm like, hey, that'd be a great thing to take a picture of, and literally 15 phones come out. Boom, 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 boom. It's really funny. Cool. Next one. Oh, I do that all the time.
Yeah. Actually, photo chat, just doing that like towards my phone.
Yeah, I do it all the time, actually. I'm always in it. So I did not do that one because that's, again, the FDR stuff, super easy. Let me see what else we got here. We did that one earlier. Did I do this one?
That one, I believe, was also in the workbook.
Oh, really? No, yeah, that's the one I also did. Well, it seems like the workbook problems were really good. I can do this one if you want, or I could skip it. Yeah, okay. Hey, I am happy to do it. I mean, this was on my list, so when I see something hard, I'm like, ooh, let's do it. So I think that it's just going to be the FDR stuff, which, if you want to know how this works, it's actually F, and then you're doing R prime, and then you're saying dt. That's basically what's going on. We have our F, so that's kind of easy. But I do need to take the derivative of my r. So derivative of sine will go to cosine. Derivative of cosine goes to negative sine. And my t goes to bam. So this, ew. So this is what I'm going to dot product with the f. Oops, don't need an equal sign there, silly Chad. So I got 4z, 4x, 4y dot, all that stuff. But before I do this, something still doesn't look right. Because it's all mixed up. I can't keep x, y's, and z's here. I need to go back and plug them in. And so instead of saying 4z, it's 4 times t, because that's my z right there. And then not 4 times x, it's 4 times sine, because this is my original. Yep. And then not 4 times y, it's 4 times cosine. Okay, cool.
So what I'm understanding with this type of problems is that r is always going to be your values for x, y, and z.
Always, yes. Always. X, y, and z. Always, yeah. My original r is always x, y, and z. Always. 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 Mm-hmm. Always. And so I got 0 to 2 pi, and then I'm going to do the dot product, which is super easy here. So 4t cosine t, I got a minus now, negative 4 sine squared plus 4 cosine. And guess where we go? Desmos! We ain't wasting time here, guys. We ain't wasting time. But I want to show you what I did in Desmos to make it easier. So what I did is actually 3 separate integrals. Because here's the thing. I saw this sine squared, and I said, oh no, that's going to have an angle, like an actual true angle. But then the sine and the cosine beside it, if you remember how the integral works, it'll also have like a ratio attached to it. It's really weird. So if I find all of these at once, I might be overwhelmed, and it might be something weird. But if I do it individually, I mean, that's a 0. Shrug. That's my answer for that. Yeah, I don't know. See, like this one, but it can't be too complicated. So that's a negative 4 pi. And then, yeah, let's do the last one. This is just a strategy, not required to do this, but if like the big answer is not giving you something nice, then maybe individual ones will. And there's your answer. Cool? Oh, please do. I am okay with notes because I'm here for you guys. I mean, I got a huge list, but that doesn't mean we have to get through it. I mean, I'm just saying, here's some things that I thought would be neat to talk about. It just so happens that some of them are on the workbook. I'm like, oh, well, I guess I picked cool problems for the workbook.
To be fair, the notes I had for some of the problems in the workbook were my other notebook at home. So I'm like, I have to figure this out right here.
Good thing math is fun.
Oh yeah. Math is fun, math is life. Literally.
Math is bliss. You look tired today, bro. I'm sorry. Did you stay up late last night? Really? Doing homework or partying? Okay, good. Homework party for this class? For this class? Oh. Okay. Are you a night person or a morning person? Oh, so you're fine then. Yeah. Tired, right?
Better, they're always tired. It's always
One or the other, yeah. Yeah. It's kind of funny. I'm a morning person, so like I have a cutoff limit. So we just did that one. This one I think I did put down. No, I didn't. But I can do it if you want, or I can move on.
Sure, let's do this one.
Cool. Cool. Let's do it. Are you good? You're good now? Okay. Reload. Here we go.
I have a question.
Yeah.
Number, is this problem? Like this like the question number.
Oh. Man, annoying. Number 9. Thank you. Okay, cool. So, this f.tds, I believe, is just FDR all over again. So the same process essentially, and that's probably why I didn't do it on my notes, but it's perfectly fine to do it again. So I've got x squared, and I got negative y. We're going to leave a little bit of room because I need to find my r. I'm going to do t squared and t. Let's pause on this. Do you note that my y is the independent variable? So I'm choosing that to be the regular t, and then that's my x. So this is my x and my y. Find dx dy. Cool. And so I could then rewrite this using t's. If that's x squared, then that's t squared squared. And if that's negative y, then that'd be a negative t, essentially. So then I could just say t to the 4th minus t dot 2t comma 1 dt. If I'm using my y value as the independent variable, it looks like I'm going from 1 to 0. Pause on that. 0? It says here, from this to that. And I'm saying that y is equal to t. So I'm kind of stuck with that. And if you see here, I have a negative in the front here. It probably has something to do with it. Go ahead. I don't know yet. We're going to just do this. It says, I said that y was equal to t right here. So I am just going 1 to 0. That's what it says. And I'm not wasting time. Desmos. That's not a 2. Beautiful, beautiful. I guess it ended up positive in the end. So even if it says like f.tds, it's just the same thing. There's nothing new here. Cool. Keep cruising. Let's see what else we got around here. That's basically the same thing. If you want me to do it, I can. If not, I'm going to keep moving. Keep cruising. Okay. Oh, wow. How nice of me. Wow. I was really generous. Oh, my goodness. Okay. I think I have this one. I don't know. I don't see it, so I could do it. No, I do have it. Yeah, I have this one. If you want me to do it, I could do it. Cool. Let's do it. Same thing. This will be the FDR business. And so I have my F, 2xy, 3y, 5. And I'm going to leave a little bit of room because I need to actually like get the t's and stuff. My r is t squared and a 1. Again, this is x, y, and z. Remember that. So then my derivative, 1, 2t, and 0. So I'm going to take this and plug it in essentially. So 2 times t and t squared, 3 times t squared, and then still a 5. So here we go. I got 2t cubed, 3t squared, 5, 1, 2t, 0, dot product, 6t to the cube, and then 0. Isn't that going to be 8? Desmos! No, I'm just joking. This one's too easy for that, right? Sure. 2 to the 4th is 16. 16 divided by 4 is a 4, so 32. Oh, there's your answer. Okay. I did it. Forgot to do that rappy thingy. It's still good. Okay. Yeah, please. As much as you like, I am happy to sit here and do nothing. I'll just drink coffee slowly. Yes. It's at 15. Thank you. Is this good times? Doing okay back there? Kind of quiet. Okay, good. Okay. Okay, good. Go ahead. They gave it to us right here. 0 to 2. Yeah, they're very nice to us once in a while. Once in a while. I didn't look at the last one. I don't know what it is. I'm just going to click on it, and I guess I didn't do it, but I can if you want me to. I don't mind. Or I can skip it. It's the same as all the others. Same thing? Or do you want me to do it? I know you're like, sine and cosine, but it's like literally the same problem. Do you want me to do it? Yes or no? Yes. One yes means a yes. Notice that this one's a little bit on the tricky side. Do you see right here? Look what's missing. And that is the only part that makes this thing hard. I feel like it's artificially hard. They're like, were you looking? Yeah, that's exact. They're just messing with you. That's it. Again, this is my X, Y, and Z, so I should be able to just toss those in there. So I have cosine minus sine, 0, and then just a plain sine, cosine, negative sine, and then 0 to pi. Make that into a pi. Okay, there we go. Good enough, good enough. So then I would have cosine times that stuff. So cosine squared minus sine times cosine. We ain't got time for this. Minus sine squared dt. We ain't got time for that. Come on, tell me what I could do in math. If I didn't have Desmos, what would you do to accomplish that? No, I'm saying if you didn't have Desmos. Yeah, it's factorable basically. At least I think it is. We would have to go back and check. But this is right here. This is a negative. I don't know if that's right. You can make one up. Exactly. Just a thought. Oh well. For reals, Okay, I don't know if that's actually it, so let's just check it out. And wow, that was annoying. But we did it. Good test question. Well, you have a skill to being able to talk math and make people confused. It's perfect. Because you're like, dude, the cosine is just like, No. Well, I mean, that's funny. Oh, you're still taking notes. Okay. I'm going to get out of this homework assignment and let's do other things. As in, like, go away, my math lab bar thingy. Okay. Oh, of course. I love when that happens. Okay. Do you want me to do some 16.3? Okay, cool. 16.3. What is it, like 3 homework questions total? Look, 2 out of 6. It's only 6 questions. And I just did 2 of them, I think. So it says, oh, the potential function. We love potential function. You're just going to be integrating in terms of each one of these and adding them together, essentially. Here, yeah, let me be really silly here for a second and show you what I think the answer is. Remember, you're integrating each one of these guys in terms of what's going on here. So z squared plus c. Is there still a plus c? Yay! Can you integrate each one of those individually? X in terms of x, y in terms of y, z in terms of z. We're going from a vector to a scalar. So I just don't have those in my answer anymore. Okay. Yeah, that's fine. So I didn't really do many potential problems. I think I did one with an E in it, which again, the E would be like, oh no, what do I do with E? But besides that, everything else is pretty easy. Does it make sense though? Just integrate. Yeah. I'm fine for hanging out, man. Yeah, that's fine. Good. We're gonna do a hard one here in a minute. By hard, I mean still easy. Yeah, I'm trying to make these this last chapter easy for you guys, deleting everything I can, with still being a good teacher, somewhat. Okay. So the same thing would happen here. I don't think I want to do that one because it's almost too easy, but I do want to do this one. Is that okay? Okay. So it looks like, oh no, there's an E in there. Was this on the workbook, by the way? Oh. It's like I only pick ones that I really like from the workbook. I'm not meaning to do that. It's just, you know. Okay, let me write this thing. Oh, no, I'm going to make it a vector. Erase. 420x, 16x. Okay, so I'm going to integrate each term in terms of its term. That was supposed to be funny. See, so I'm going to do this guy, and then I got my 20x in terms of the y, and I got 16x in terms of the z. So each one of them individually integrating. But I don't even have an x for this first one. So what do I do with the next? That's it. That's all we do. And then, oh my goodness. I know, right? Almost got a 0. In terms of y, notice we're integrating, so I have to divide by the number up in the power. So 20 divided by the 5 makes a 4, which, go figure, that's the same as this one. And then for this one here, I'm going to divide by the 4. And everything else is the same. So I'm looking for common elements. I need a little bit of everybody. You see that this is the same as all those other guys? They're all the same. So that's my answer. We're done. What analogy did I use for this? Do y'all remember? Was it something to do with pizza? Oh yeah, pizza and breadsticks. I was like, okay, well, I'm going to go buy pizza. So, oh, I want pepperoni. Well, I want cheese. So I'm like, okay, well, I guess I'll have to get both because someone's picky here. And then Henry says, no, I want breadsticks. So, I guess I'm going to have to pick up breadsticks. But if 5 of y'all are wanting pepperoni, that's fine. I'll still buy pepperoni. Like, I want pepperoni. Fine, well, I'll just go buy pepperoni as well. Just write down whatever, take everyone's order. Here, everyone wanted the same thing. Everybody wanted pepperoni pizza, so I didn't really have to do anything. But the last one, everyone wanted, I want pepperoni, I want cheese, I want olives.
Then you may have taken derivative instead of integral.
That's a funny one. That's good. That's clever. Okay, so potential functions, they're pretty easy. Oh, look at that. How nice was I? Is this one that I did? I think I did this one. Yeah. So I would love to do this one with you. I don't think I did this one in class. Can I do it with you? So when I approached this one, I actually wanted to approach it the way they wanted me to. In a way, I could do the FDR like I always do. I could make a path, and then I could go and do all my same derivative stuff here. It would be easy to do that. But because we're talking potential functions, I'm simply just going to do the potential function thing. So if my f is y, x, and 6, then I want my potential function. So I'm integrating y in terms of x, I'm integrating x in terms of y, and I'm integrating 6 in terms of z. So what would I end up with right here? X, y, x, yes, plus c, and then this guy? So 2 people want pepperoni, and then this guy wants cheese. So then I have to go and buy a pepperoni and a cheese, and then some breadsticks because everyone likes breadsticks. Nobody actually eats the breadsticks, it's only me. That's fine. Me and Henry. But I want to note that I am not having 2xy. It is not 2xy. Okay, that would be too much pizza, right? Someone says, I want pepperoni, I'll go get you some pepperoni. I ain't buying 2 of them. Y'all share the same pizza.
So I have a question.
Yeah.
So essentially, with this, we're just basically looking for the common thing. We're having
Yes.
that as our center, then we're adding whatever the other options are.
Yes.
Okay.
Yeah, I like that.
Oh, which one makes sense is if you take the derivative and get back to your original problem.
There it is.
Yeah.
That's exactly right. If you took your derivative, you get back to where you wanted. Exactly, perfectly right. This is just the implicit form. We're just going back to the original.
Right.
So this one's super easy to do. What they want is it's f of b minus f of a. This is fundamental theorem of calculus kind of stuff, which y'all all totally remember.
Oh, yes.
No. Just like random math terms. Yeah. So I'm going to just plug that into each one of these and get some numbers. So then I got 4 times 9 plus 6 times negative 2 for this guy. So there's my first one. And then minus, and then everywhere is just 2's. Like that. Calculator for sure. So 4 times 9 plus 6 times -2. 2 times 2 plus 6 times 2. 24 minus 16 is 8, and that's the answer. So yeah, all this equals 8. I kind of scrunched myself at the end. I'm sorry. So that's how they want you to do that problem. I honestly find it super easy. It's not always useful, like going into the other sections. I wouldn't always do that, and we could do FDR if you liked, but 4 times 9, yep, 4 times 9, you got it.
So essentially just plugging those numbers back into the original formula.
Yes, yes, yep. That's the concept of this section. Cool. Good, good, making sense. Yeah, just plug it in, right? We got time. We got plenty of time. Plenty of time. This one is the same way. I don't think I did it, but I can if you want. And oh, well, that would be it. Want me to do it? I don't mind.
Sure.
Let's do it. So yeah, I have not done this one yet. I just saw it and I was like, I think that's not too bad. Notice that we got only I and J. So, and it has X, Y, and Z. So I'm wondering if I have to make that last one a 0, essentially. So I'm a little bit iffy on this one. Okay, so I'm going to start integrating. So 8x over y in terms of x. The 8 and the y are both scalars. So I just do that with my x. Now in terms of y, that's technically a -2. So I add 1 to the power, divide by the new power. So I put a negative in the front. And then I got basically divide by a y. And then what's my integral of 0? Yes. You cannot add an extra number from that. It's just 0. Plus c! Sorry, I don't know if I can actually add a plus c for that. That doesn't feel right. When I'm looking here, I got 4x squared over y, and this one is a little different. Let me make this a little bit more funny. It's -5 over y plus 4x squared over y. You see that? So he said, no, I want cheese and pepperoni. So I'm like, well, why don't you just eat pepperoni? But okay, fine. So I guess if I had to take like a common potential function element thingy, it would be this guy. Because he has kind of like both. Go ahead. For the 0? Okay. Well, okay. Well, if you say so. I'm still going to be cautious about it. And they didn't want me to integrate or nothing like else. So that was it. We're done. So that was pretty straightforward.
That one wasn't too bad. I saw the y graded to 0. I'm like, okay, it's just gonna get some sort of mess. Like, it's just...
Yeah, I think they just don't want a domain issue. They're just trying to cover their back sides.
Yeah.
Yes. Okay. Good. Yeah, I'm fine. I'm fine. Are y'all cool with why I chose that?
Yes,
Yeah, and then it has its own thing. Yeah. Pizza and breadsticks. Yep. Plus C. Wow, that was an easy section. Yay. I got some time. I would love to keep going. Yeah, I got a lot. Like, I just get more and more from here on out. And again, if you find one or if you say, hey, I want to do that, I'll do it. If you say no, Chad, don't do it, then I don't.
I'll try to get as much of this done today as I can. Questions tomorrow.
Yeah, questions are good. But again, even if you don't have questions, I have questions. So either way, no pressure either way. The curl thing is so easy. I think you're just doing like the gradient, and then you just take the z component. I can't remember. I didn't do any of these because I just thought it was too easy. But maybe I just skipped over too fast. What do you think? Want to do one? Kind of like a refresher. So I literally cannot remember the formula for curl. So I'm gonna go and get it right quick. So when I forget a formula, you go and look it up. No, on exam you wrote it down already. Yes, you did actually on your tiny note card. Right here. Oh, there's your formula. It's right there. So nx minus my. That's it. That's it. So let me get that other sheet of paper up. So they're wanting nx minus my. That's literally all we're doing. And again, that's m and n. So what I'm doing is 3xy in terms of x minus the 9x plus y in terms of y. Look at that cool notation. Yeah. Newton is just like, what are you doing? So what's my derivative of this in terms of x? Done. Minus sign. In terms of y, I get a bam. Complete. Good thing we had a formula for that. Yay. Formula time.
I'm not gonna lie, I had to refocus my mind because I saw the I'm like, oh, X bar, Y bar stuff. I'm like, wait, no, James, this is a different format.
Yeah. Yes. Yes, I was just rewriting this down. I'm just copying it down.
And with this one, I is always going to be the N, right? And then J is always N.
Yeah. It goes M N O. Oh. I think they use P.
Yeah.
Because O looks like a 0.
Well, I believe in the word we only had to deal with the 2 dimensions, so or the 2.
Happy times then. Happy times. Same thing. I'm not worried about it. That's why I didn't do these because it was a very simple. Oh no, cosine. I think you can handle it. Okay, this one is different. I did not do this one, but it might have been in the workbook. I can't remember. Oh, this particular problem. I did this one. This is the one I did because I thought, oh, well, it's a little tougher, and I think this might have been in the workbook, but I can do it again if you want, or I could do the harder one.
I'd say do the easier one since we have about 5 minutes left in class time.
Okay. If you say so. So Green's theorem, if you go back to the formulas, which I'm going to really want to go back to and see them, we have 2 different things we need. See how it says flux? And here, flux. Oh, come on. Okay, here we go. Flux versus circulation. And so we have these 2 formulas right here. So mx ny versus nym or nx my. Basically, we're doing the same thing we just did, but we're going to integrate and it'll be okay. Are you copying those down? Oh, okay. Good. Don't, because I'm going to do it again here in a second. Okay, so here we go. I got, for my flux, it was actually the bottom one. I believe it was mx plus ny. Was I correct about that? And then the circulation was the top one, which is my nx minus my. Okay, so what I did is, you can see on my paper, I got it wrong. It's because I did the top one first. I flipped them. So I was like, why am I getting this wrong? It was because that was the answer for number 2. Fine. Anyways, so m in terms of x, what do we get? 1. And in terms of y? So notice what's going on here. I'm saying 6 times my area. Yeah? I'm just going to write area, 6 times my area. Let's do the same thing down here and see what happens. So n in terms of x. And minus. And then this one in terms of y. So 2 negatives make a positive. Ooh. Well, that's an easy answer. So the only thing we need to do is find 6 times my area. It says the square bounded by this. What do you think my area is going to be? You're going way 25.
I'm thinking integration, not just basic.
Right. And 6 quarters makes $1.50. And the other one's 0. There we go. Cool. See, we should have done a harder one because now we still have 2 minutes.
Yeah, I thought it was going to take longer.
Well, it would have if we did integration.
Stop judging me, Chad.
Okay. So we can pick back up on this if you want to next time. Would you all be okay with that? Or y'all find questions? I'll do those first. I love doing them. But again, significantly reduced. What is there should not be too bad. If we find something bad, I don't mind deleting it. I just want to make sure that y'all are happy and getting it done while still giving you content because I need to because I'm a teacher. Okay, good. So thank you guys.